There we go. All right, completing the square. So when we talk about completing the square, this is essentially a strategy we use when we want to convert from what we know as vertex form to standard form after we expand it. Or if we're given a quadratic that not necessarily might be perfect in terms of factoring it using just essentially Foil-Box method, or more or less reverse factoring it, basically, I should say, or basically finding by using quadratics and we get some crazy function with a radical in it. Well, there is another way to at least get somewhat of a perfect number, and that's by completing the square. What the completing the square says, essentially speaking, is that by changing the middle term, essentially by applying the middle term half of the middle term, and then adding it to the end, and moving the last term to the other side of the equal sign, you could actually factor what you come up with. Now, I know that sounds confusing when I say it at first, because in reality it is, but it'll all make sense in due time. So let's take a look at these examples up here at number 1. This right here is a comprehensive list, basically, on what you're going to be doing, okay? Your instructions, basically. Okay, first, complete the square, follow the steps 4 and 5 of the instructions above. Okay, so we got 4 and we got 5. Calculate half of b and square the value. Calculate the number to both sides of the equation and put in a box. So what that's basically saying is that if we take half, so let's say this is, we'll look at 20 first. So essentially we take 20 here, and there's basically 100 right here, okay? And what it's basically saying is if I take half of 20 and divide it by 2 and square it, is how I got that number. That's called completing the square. You're literally taking the b term, dividing it by 2, and squaring it. You're applying this equation, basically, okay? Or the fact of the perfect square trinomial, all right? Or not that equation, sorry, but you're applying this portion of the equation, the b over 2 right here, not the x. But you're basically using b over 2 squared, okay? So 1 divided by 2 would be 1/2. 1/2 squared is 1/4. Okay? Well, it'd be also, and yes, here's the thing. You'll notice that has a negative on there. There's a negative 1 over 2 squared, but it came out to be positive. You will never have a negative value if you do complete the square, because it's in parentheses and it's squared. If you get a negative value, something's wrong. Okay? Might want to make a note at the bottom. Never have a negative value. Okay? You will never have a negative value. All right? This one you have 4 over 2 squared. Okay? 4 divided by 2 is 2. 2 squared is 4. All right? Now, some of these you'll notice still can't really be factored. There will be some exceptions in this.
It's always just the middle term.
Yes, it's always the middle term, and it's always divided by 2. Some of these you'll notice really can be factored. We could do the 100. That'd be 10 and 10. That'd be easy, right? That one's easy, at least. 4, unfortunately, that one's not perfectly square. It can't be perfectly squared. So there are anomalies. Unfortunately, I know. Terrible plan. Okay? Now, the next one we're going to talk about. So does everybody understand the concept of basically just finding the last term to complete the square if you're given 2 numbers, right? Well, you don't need trickery there. You can really find it. If you're just given x squared plus x, you can find it. X squared minus x, you can find it. Doesn't matter. As long as you're given a and b, you can find c now. Yay. You only need b, but realistically, you want the square there because it tells you it's a quadratic. All right? So let's go down to number 2. All right? So number 2 says complete the square. So now we're going to use completing the square to solve this guy. Notice that there's already a number in c. For completing the square, we throw that logic out the window and we say, no, I don't want it there. And we're going to move it to the other side. So what we're going to do is we're going to add 12 to both sides. What that's going to give us is x squared plus 4x plus, and we're going to use a box right here, equals 12 plus, and then we're going to put another box. The reason why we put the boxes is because what you do on one side, you'll do the other side. If you look to step number 3 on here, okay, so we've done so far is change f of x to 0. They already did that for us. If the leading coefficient is greater than 1, divide everything. Nope, we're good to go. Isolate the constant and put plus box on both sides of the equation. What we're basically doing here is one of the basic laws of equality. What you do to one side, you have to do the other side. Okay? Mathematics at its finest. So, we've got our boxes on both sides. Now we got to figure out what the square would be. So again, we're going to take this term and divide it by 2 and square it. So we're going to take 4 divided by 2 squared, all right? And what we get is what? 4 divided by 2 is 2. 2 squared is 4. Put 4 here, and you put 4 here. Okay? What we get from that, right? And actually, that is a perfect square. We can do x squared plus 4x plus 4 because it could be 2 and 2. Yay. Right? So we factor that, we get x plus 2 squared. Then you simplify this, and you get 16. I know I'm skipping some steps in terms of showing the math, but realistically, I'm just doing it to save space. If you need to see what I just did there, I need two numbers multiply together, give me 4. Add together, give me 4. The only options are 2 and 2. Okay? And we get 16. This is our answer. Realistically. Now, if you want to go one step further, you could, right, then solve or move 16 to the other side. If we move 16 to the other side, guess what? It just became vertex form. Right? If we move 16 to the other side, here, I'll do it in a different color. Here's our extra steps hypothetical. If I move 16 to the other side, I get x plus 2 squared minus 16 equals 0. That's vertex form, everybody. You see how powerful this is? Okay? Let's do another one. Let's do number 3. Okay? Number 3. We go x squared minus 12x plus 7. Okay? Again, we take x squared minus 12x plus a box equals negative 7 plus a box. Okay? Okay, from there, we're going to take negative 12 divided by 2, and we're going to square it. We get what out of that? 36. Put 36 in both spots. Sorry, I did not think that through. It's too squished. Can't even read that. I can't read that. Let me come in again here. There we go. That's better. All right, we got 36 and 36. So now we need two numbers that multiply together to give me 36, add together to give me negative 12. 36 and negative 12. The only options being are negative 6 and negative 6. Okay? So that means we'll have x minus 6 squared equals, and then 36 plus negative 7 gives me negative 29. Add 29 to both sides. And I get that f of x is going to equal x minus 6 squared minus 29. And realistically, this is the answer form that I want it in. Hypothetically, if you stopped right here, you're not wrong. It's just, it could be nicer. Personally, I'm not going to throw such a hissy fit over that, but for this portion of where you're at in math, I do want you to write it as f of x. Yes. Okay? Now, notice something. The first one was a perfect square, right? The second one was a perfect square. Once is a coincidence. What is it? Once a coincidence, twice is a... No, once is a fluke, twice is a coincidence, 3 times. Pretty darn obvious what would be going on here. So do you think would it be unfair to assume that, and break a rule of mathematics, because I usually don't assume math, but if we did, it's not entirely left fielded to say, hey, I think the next one's going to be perfect square again. Let's find out. Okay, and just to drive the point home over here real quick, this should be f of x equals x plus 2 squared minus 16. Sorry, I forgot to write that there. All right. Now, let's take a look at number 4. So I'm going to make a prediction that it's going to be a perfect square. Okay, let's see if I'm right. First things first, we've got to move this 10 to the other side so that we get x squared plus 12. Whoops, I should rewrite that, so not 12. Rewrite it in the right order we want it in. We want the x in the middle. Okay, so minus 10x plus 12 equals 0. Okay? So we have x squared minus 10x plus a box equals negative 12 plus another box. Now, something to keep in mind. Okay? 1, you don't need to keep writing b over 2a squared. Let's be realistic. Because you can take half of 10, which is negative 5. Negative 10 is negative 5. Divided by 2, you get 2.5. No, sorry. Negative 10 divided by 2. I don't know why I just did that. Negative 10 divided by 2 is negative 5, and squared is 25. Okay? 2 terms that multiply together to give me 25, add together to give me negative 10. There's only one option, negative 5 and negative 5. Okay? So we have x minus 5 squared equals negative 12 plus 25 is 13. Subtract 13 from both sides, and I get f of x equals x minus 5 squared minus 13. Huh. My assumption was correct. Ladies and gentlemen, when you use perfect square, you will always get a perfect case. That is why it's called completing the square. You are making it to where you're completing our square value so that we don't have to worry about some ugly quadratic equation. All right? Everybody understand so far? All right. Now, just because I know some of you guys are still writing number 4, I'm going to jump down to 7, and then 6, and then 5. So we'll go back across the other direction. Okay? Now, rewrite the equation in vertex form. Then find vertex in the y-intercept. Okay? So we need to rewrite this in vertex form. We can do that by completing the square. All right? First step, of course, is we need to rewrite this so it says equal to 0. So negative x squared plus 4x plus 1 equals 0. Okay? So then let's complete the squares. We have negative x squared plus 4x plus a box equals negative 1 plus a box. We have negative 4 over 2. You'll notice that I just put a negative in there. It is the opposite of b over 2a, by the way. Just so you know. Okay? So just so you're aware, that's what's going on there. If I do that, I get 4, because negative 2 divided by 4 is negative 2. Negative 2 squared is 4. So we have 4, and we have 4. Okay? So now we need 2 numbers that multiply together to give me 4, add together to give me 4, and that means it's 2 and 2. So, after all that, we have x minus 2 quantity squared equals negative 1 plus 3 is 4. So our vertex so we can get it right here, is going to be, and we also need our, what do I want, the vertex and the y-int. Okay? So then we can rewrite this as y equals x minus 2 squared and subtract from 3, moving 3 to the other side. Okay? And then, now here's something you can also do. I don't like having a negative on that 3. Okay? I really don't. So I can multiply this whole thing on this side by negative 1. And I get negative x minus 2 squared plus 3. Okay? Nothing wrong with doing that. So I'm just multiplying the whole thing by negative 1. Though, to be honest, honestly, I don't like doing that. Let's find out something. Let's plot this guy real quick. I want to graph them real fast. I want to see something. So let's put in the one before I did that multiplication there. So x minus 2 quantity squared minus 3 graph. Of course, if we do that negative, it's going to flip the whole thing. So I'm going to say no, don't do that. You don't need to do that. Okay, I think this my template I have here had a typo. All right. Y equals x minus 2 squared plus 3. Okay? And after we do all that, and if we graph it, you can see there's the y-intercept, which you could have found just by calculating it. But the y-intercept is going to be 0, positive 1. And the vertex is going to be 2, 3. And there's your answer for that one. Okay? So does everybody see how powerful this is and how useful this can be? Right? You've got so many tools now at your disposal just for solving quadratics. It's insane. All right? Let's do number 6. So number 6 and 5 are basically the same thing as number 7. Okay? First things first, rewrite this guy so that the C term is on the right side of the equal sign, set it equal to 0. So we'll have 2x squared minus 8x plus 1 equals 0. We move to the other side, so we'll have... Now, remember... Oh, I almost forgot something. Notice, remember number 2, the step for number 2? If the coefficient is not greater than 1, if the coefficient is greater than 1, guess what we do? Divide the whole thing by that term. So you're going to divide the whole thing by 2. And I get x squared minus 4x plus 1/2 equals 0. Okay? From there, I'm going to get x squared minus 4x plus a box equals minus 1/2 plus a box. Okay? I take negative 4 divided by 2 and I square it. And that equals, and that should actually be a positive 4 in that other one. I'm sorry, by the way, another typo. Okay? And we get 4 out of this. Plug them into there. Okay, put 4 here. So from there, I need 2 terms. Again, that multiply together, give me 4. Add together, give me negative 4. They're going to be negative 2 and negative 2. So I have x minus 2 squared equals 1/2 plus 4 is going to give me 3/2, right? So you can either write 3.5 or 3 1/2 or whatever you want. Whatever works, okay? Or 3 plus negative 1/2. I may have said that wrong earlier, sorry. Okay, and we do all that mess, okay? We add this back to the other side, and we get x minus 2 squared minus 3.5. But we're not done. Here's the thing. I don't like that fraction. Get it out of here. So what I can do is, while it's still set equal to 0, before I set it back equal to y, is I can multiply the entire thing by 2 again. The entire thing. This is where you would want to do what I was trying to do in the last one. Don't do that. Do that here. Multiply this entire sucker by 2. And I just realized something actually on the last one we'll need to go back and fix. I think I realized what I did wrong. And I know why that I need to do that. And I'll explain here in a moment. Okay? Multiply the entire thing by 2. And we get y equals 2 times x minus 2 squared minus 7. So the vertex would be 2, negative 7. And the y-intercept would be 0, 1. Now, a typo on the last one. while I have everybody's attention in this video, and I want to explain something. I did mess up. I was right when I wrote down the first time. Can't say with your first answer. I didn't realize why I wrote it, and I remember. That was a -1 in front of this whole thing. I actually did it subconsciously, didn't realize it. I divided this entire thing, or should have divided this whole thing, by -1, which is where that -4 came from. So this whole problem here needs to be fixed in regards to this, because this whole thing was divided by -1 because the leading coefficient was negative. We need to get rid of it. That should be positive. This should be negative. That's still positive. So that means what's in here is negative. Okay. Let's see, that fixes that. That's fine. 3. So then, when I did that, brought that back over, where I had x minus 2 squared minus 3 equals 0. When I was at this step, I need to multiply this whole thing by -1. I did the same thing here. So whatever you divide by, you have to multiply back in before you get rid of the, before you set equal to y, okay? Equal to y. So then you get what you need to out of this, which was y equals -x minus 2 squared plus 3. Vertex is still the same. The only change is that there'll be a negative on that 1 right there. That's it. So I apologize. There was a typo there. That's my fault. Okay, so everybody got that fixed? Yes? Okay, good. All right, last one we're going to do. And then I'll let you guys start working on your homework because we have some extra time. Yay. All right. Rewrite the equation in the vertex form, then find vertex and y-intercept. Okay? So first things first. What do we do? Set it equal to what? 0. Set it equal to 0. I'm going to ask you guys. I want the steps now. Okay, we've done a bunch. You guys should be masters at this now. Equal to 0. The next step I got to do. Look at the steps. They're right up there, guys. What's step 2? What's step 2?
Oh.
Literally read it right there. Top. Somebody read it for me.
If leading coefficient is greater than 1, divide everything.
That means, is it greater than 1? Nope, it's not. So we don't need to do anything. Number 3, what's the next term? Next step?
Isolate the constant.
Yep. So we'll do x squared plus 4x plus a box equals +7 plus another box. What's the next step? What's the next step?
Isolate the constant and put plus box on both sides of.
Well, we already said that. What was the next one? Number 4. It's okay.
Calculate half of b and square the value.
Yep, calculate half of b and square the value. Okay? So we take 4 divided by 2 and square it. We get 4 back. Plug them into here. 2 terms multiply together, give me 4. Add together, give me 4. They are 2 and 2. That basically right here is step 6. Or sorry, calculate. No, 5. Add the number to both sides in the equation. So we did number 5. Sorry, I skipped 5. I just did 5 for you. There you go. Add the number to both sides. This is step 6. What that's basically saying is that it's basically a perfect trinomial. Okay? I don't know why they call it trinomial, because technically it's a binomial, because it's technically squared twice. But, semantics. Okay? Or is it? No, it should be binomial. I don't know. I'll double check that later. For right now, that is bothering me. All right, nope, trinomial's right. I just checked it. We're good. Okay. So from there, we then would factor the perfect square trinomial. Okay, this is a perfect square trinomial. It's just going to be x. Let's see. No. Yes. Okay. So we then would have x plus 2 squared equals 11. Simplify the side, that becomes 11. 7 plus 4. Obviously, the square trinomial will be x minus b over 2, but in this case, it needs to be positive. Okay, so it'd basically be divided by 2. We're good to go. Okay. So from there, we would then subtract 11 from both sides. I get y equals x plus 2 squared minus 11. I don't need to multiply it by anything, right? Because I didn't have to divide anything by the leading coefficient. So we're done there. Yay. So that means that my vertex, my y-int, the y-int, again, after just looking at it, it's basically -7. It's up here. Might as well grab it. And the vertex is what? Here and here. So it's going to be 2, -11. Oh, sorry, -2. Opposite of h. Opposite of h. There we go. -2, -11. And that's how you find completing the square and how you can use that to find vertex and y-intercept. Very powerful tool. I highly recommend you use this, especially on your test. It can be very, very helpful, especially if I give you a standard form equation. I'm saying find the vertex. You want to find it fast. Okay?